So now that we've learned about electricity and magnetism, we're going to talk about how they're related to each other. And a fancy way of saying that is electromagnetic induction. That just means that electricity causes magnetism and magnetism causes electricity. And then these are two little contraptions we're going to talk about today. This one on the left is an electromagnet. That's using electricity from a battery to cause a magnetic field around a wire. And once you connect the wire to the battery, the nail can actually pick up paper clips because it's magnetic. And then the opposite of that is using a magnetic field, which it's hard to see in this picture, but there's a magnet inside this cardboard box. It's kind of like right there. And there's wire wrapped around it, and then it's connected to a light bulb. So when you spin the magnet inside the wire, which is wrapped around the box, then the magnetic field causes electricity and lights the light bulb. So don't worry, we're going to talk about it more, but here on the left, it's electricity from the battery causing a magnet, and here on the right, it's a magnetic field from a spinning magnet causing electricity. So let's go a little bit deeper into that. So the first one I talked about, electricity causes a magnetic field. We're hopefully going to do this in class if we can, or we might do it on a Friday. You can even do this at home. Like if you're doing online school, you can do it at home. If you've got like a D battery, some copper wire, and a nail, it's pretty cool. So you just wrap the wire around the nail, and if you wrap it different numbers of times, it actually affects how strong the magnetic field is. So that's a fun thing to experiment with. And then after you've wrapped it around the nail, you hook both ends to the battery. And once you hook it to the battery, you got to be careful because it gets really hot because the electricity flowing through heats it up. So I usually have my students like try and use gloves to hold the wire on, or you could use a battery holder. Anyways, once you have it connected, then like I said, it'll pick up paper clips because it's magnetic. So that's electricity from the battery causing a magnetic field around this nail so that the nail will pick up paper clips. And then this picture here on the right kind of demonstrates that a little bit more. It demonstrates why it works. So this right here is a wire. Oops, I got to turn on my pen. Here we go. So this right here is a wire, like a copper wire, right? And then the yellow dots are electrons moving. And we already know that electricity is electrons moving. So you can see the electricity is flowing through this wire. But around the wire, these circles represent a magnetic field. So when electricity is flowing through a wire, a magnetic field is formed around the wire. So then when you wrap the wire around a nail, like over here on the left, you basically are stacking a whole bunch of magnetic fields on top of each other, and then the whole thing becomes a magnetic field. That's what that is supposed to be. I just drew a magnetic field, okay? And then that's why electricity can cause magnetism. So that's pretty cool. This is an electromagnet. Electricity causes magnetism. Now let's talk about the opposite thing. Magnetism, a magnetic field, can cause an electric current. Let's look at the picture on the left. That one is a little bit simpler. You can see that in the middle we have a magnet, and you can see that it's spinning too. These lines are supposed to represent that it is rotating and spinning around, right? And then up here and down here, the yellow things are wrapped with wire. So the wire's wrapped around those yellow things, and then it connects to the light bulb. So when you have a spinning magnetic field inside wire, that's why it's surrounded by wire, then it causes electricity in the wire. But it only works if the magnetic field is moving. If they didn't spin this magnet here in the middle and just had it sitting there, then the light bulb would not turn on. It only works if you're moving the magnetic field, and an easy way to move it is to spin it. So a lot of the times in generators, that's what they'll do. They'll have a spinning magnet surrounded by wires, and then it causes electricity in the wires. This picture on the right is similar. It's just kind of harder to see. There is a magnet on the inside. You can barely see the corner of it poking up right there. That's supposed to be a magnet, and that magnet is also spinning. That's what this arrow is supposed to show right here. Like the magnet is on a little rod, and then the rod is spinning. You can see that inside this box, the magnet is inside the box, and then around the outside of the box is a coil of wire. right? And then when you spin the magnet, a moving magnetic field causes electricity, and it lights up the light bulb because it causes electricity in the wire. Now, you don't have to know all that, all the complicated reasons why that happens. All you need to know is that magnets can cause electricity and vice versa. Electricity can cause magnetism, okay? You need to know that they both cause each other. You don't need to know how to build a generator. That's kind of complicated. These are simple ones, but they have complicated ones too. And I have an example of one. I know I'm this tiny little square in the corner, but hopefully you can kind of see this generator. This is a hand crank generator. It's really simple. So the yellow handle is what I would crank, and then it's connected to wires, and then there's a light bulb on the end that's connected to those wires, okay? And it works basically the same way. There's a magnet in there and a coil of wire, and when I crank it, it spins the magnet. I know I'm like this tiny little square, but hopefully you could see that the light bulb lit up. As I was cranking it, I was spinning the magnet, and then it caused electricity and lit up the light bulb, okay? So that's magnetism causing electricity. Now, this is the last thing you need to know about this. You need to know how to analyze data. So we're going to ignore the bottom table for now. Let's just look at the top table. So this is an electromagnet. I'm going to go back and show you what an electromagnet is again, if I can find my mouse. Here we go. This is an electromagnet, right? It's where you wrap the wire around the nail and then hook up the wire to a battery and it makes a magnet, okay? So with an electromagnet, in this case, with this data, they used one battery to make it, which is what I showed you in the picture. Sometimes they use more than one battery, but this is with one battery, okay? Number of coils is how many times they wrapped the wire around the nail. And then number of paper clips picked up shows how strong it is, because if it picks up more paper clips, it's probably a stronger magnet, right? So take a look at this data for a minute and think about what you notice. You can pause it if you need to, but hopefully you notice that when you use more coils of wire, the magnet gets stronger. We've got 20 coils of wire, you pick up 16 paper clips. With only 5 coils of wire, you only pick up 4. So it gets stronger if you wrap the wire around it more times and have more coils, right? So that is how you would analyze that data, okay? And I think that is the last little bit. Yep, that is. So I hope that helped prepare you for the test. Good luck.